Welcome back, Pre-Algebra. We're in lesson 33 today. So today we're going to talk about having more than one unit multiplier. So up until now, we've been doing things like 12 inches, converting that into feet, right? So we know that would be 1 foot because we know there's 12 inches in a foot, right? So, but that's what we've been doing. We've been doing one step, or we've only needed one unit of reference. Now we're going to be doing things where we have more than one unit of measure. And this can require a little bit more of a thought process where you have to know how to get from one to the other. So for instance, if I gave you inches and I asked you to convert it into yards, you would need to be able to understand the amount of inches in a foot and the number of feet in a yard, right? So you'd have to go from one to the other, not just from one to the next, but you'd have to make 2 steps instead of one to get where you need to go. So let's jump into example 33.1 so that I can illustrate that for you. So in this problem, we are going to convert 360 inches into yards. Excuse me, I got a frog in my throat. So in order to do that, we need to first understand how we need to get there. And the way that we need to get there is to go from inches into feet and feet into yards. So we are going to need a reference that says how many inches are in a foot. So we know that there are 12 inches in 1 foot. So now, though, our ultimate goal is yards. So now we need to go from feet to yards. So we know that there are 3 feet in 1 yard. And yard is where we're going, so that is where we can stop. We don't have to go any further. So we're going to do the same thing we've been doing. We're going to take 360 inches and we're going to turn it into a fraction. 360 inches over 1. That's our first step. Now we're going to turn inches into feet by using our unit multiplier. And we need to have inches on the bottom so we can cancel out that unit of measure. So 1 foot times 12 inches, 1 foot over 12 inches. That allows us to cancel inches and cancel inches. And if we were just going to feet, we'd be done, but we're not. We're going to yards. So now we have to turn feet into yards. So we're going to do the same thing, and we're going to put 1 yard in the top and 3 feet in the bottom because it takes 3 feet to make 1 yard. So we're able to cancel feet now. Okay? So now our unit of measure that we are finished with is yard, right? We are in yards. That's what we have left. And that's where we were going, so it matches. So now we're done with our calculation or our setup. Now we can do our multiplication. 360 times 1 is 360. And now we have 12 times 3. And that is in yards. Now, typically, this is the answer I want to see. Okay? Typically, this is the answer I want to see. But I will give you an exception. And the exception is this. I'm going to pull up my calculator so you can see it. You can test your answer. I'm giving you some what's the word I'm looking for? Authority over your answer. When you have an answer like this, or when you have a result like this, and you can see that 12 times 3 is 36, right? So one of the things you can do is to test your answer. If your answer is a whole number, then you may answer in that whole number. So what you can do is you can either type it in like this and just move on, or you can say to yourself, I know what that is. That's 36, and 360 divided by 36 is 10. If you can do that in your mental math capacity, if you can solve the answer without having to pull up the calculator, like we solved it without needing that, then you can answer that way, okay? Because Saxon is all about the mental math capacity. However, not everybody's there. So I will allow you to use your calculator to check your answer. So you can check it and see if it is going to be a whole number. So the first thing I would do is get rid of all my multiplication, perform any operations in the numerator, perform any operations in the denominator. So that would be 360 over 36 yards, right? We know that 360 is just 36 times 10. You can check it and make sure 360 divided by 36, we know that's just 10. That's 10. So if your answer is a whole number like this, you may type that in. And what I will do is I will give you the option to type in that or that. However, if this answer here, if you do the calculation and this is a decimal, I don't want it. I want this. Okay? If you can get a whole number, that's fine. But I prefer this if you get the decimal. So if you can look at this and mentally, in your head, right? You see it. Oh, well, that's 10 yards. That's fine. Or if you want to check it with a calculator and you come up with a whole number, that's fine. But if it's really big numbers that you can't possibly do in your head, just leave it. Just leave it. Right? If this right here is too much for you to calculate in your head, just leave it. Because this is always going to be an acceptable answer for you to type into the system. Always. Okay? This is possible, but this is always going to be right, no matter what. So you don't have to do the math. Okay? Let's move on to 33.2. I have spent enough time kicking that dead horse. We will do some actual problems now. 33.2. So 33.2 is going to ask us to convert 1.4 kilometers. We want to turn that into centimeters. Oh, Miss Tracy, it's the metric system. I hate the metric system. It's okay. If you would click on the materials for your class, and the way to do that is to go to your to-do list, click on the name of the class, pre-algebra, and you're going to see all your assignments right underneath. But at the very top, by where it says pre-algebra, you'll see a little file folder icon in a circle. Click that. And all of the materials for class, a copy of the textbook, as well as something that says algebra reference. Click that file. That's going to give you your kilometers and your centimeters and how they relate to one another. All of your conversion units are going to be on that piece of paper. And you can print that out or write it down if you don't have a printer and keep it handy, right? Write it on the back cover of your notebook so you know that 1,000 meters is 1 kilometer. And then you'll know that 100 centimeters is 1 meter. You might not know it by heart, but you'll know it by flipping over to the back cover of your notebook and having that unit of reference handy. Now you can put it there, or another good place to put it would be on the inside cover of your notebook on the front, because you're more likely to be able to just flip to that quickly. So figure out where you want to put that. You might want to even reserve a page in the back of your notebook so that you have all your handy references. All right, so now that we have our handy references here and we know how to get from kilometers to meters, meters to centimeters, right? So that is the key You've got to have something tying the two units together, right? So you can't just go from kilometers to centimeters. You have to have something that goes with them. So if you find out, you see this, right? This is what's going to tell you. 1 kilometer is 1,000 meters. So that means you need to look for meters. How can I go from meters to centimeters? So then that's when you go, okay, let me look at my meters and what is my unit of reference there? So you could say, oh, well, meters to centimeters. That's where I need to be. So use your reference information and figure it out. It's like a roadmap. You got to go from point A to point B to point C. Okay? So we're going to do the same thing we did before. 1.4 kilometers is that's our initial. We make that a fraction, just like that. Now we want to get rid of kilometers. And so our unit of measure that has kilometers in it is here. So we put kilometers in the bottom so that we can factor it out. Boom. Now we have 1.4 times 1,000. That's meters. We've converted into meters. But we don't want to stop at meters. We want to go to centimeters. So we're going to do it one more time. We're going to put meters in the bottom and centimeters in the top because that's where we're eventually going. We're going to cancel out meters. So now we can do the calculation. We have ones across the bottom, which means that this is just a whole number. It's no longer a fraction. There is no division that has to take place. So we can put 1.4 times 1,000 times 100, and that's in centimeters. Now, as I said before on 33.1, this is one of those problems that you can do in your head. I will always take this as an answer. You can always leave this. This is just fine. So 1.4 times 1,000 times 100 centimeters. That is a correct answer, and it is in the system, and it will mark it correct when you put it in. But because this is just ones and zeros, we know that we can turn this into an answer mentally. We don't have to even pull out the calculator. It's just moving the decimal place. So we have 1.4, right? 1, 2, 3, 4, 5 zeros. So we're moving the decimal place 5 times. So 1, 2, 3, 4, 5. And then we put our comma in. So we have 140,000 centimeters. This will also be in the system because it's easy. When it's easy, when it's just moving the decimal place like this, then I am going to allow you that opportunity to put that answer in. If this were really difficult, I might not do this, but the answer is a whole number. There's no decimals involved. It's a whole number, and it's easy to do with mental math. But again, I will always have this original calculation as the answer, as a potential answer. And I actually like to see this because if you do this, then I know that you got the right factors in the right place. So if you don't want to do this part, don't do it. Do this. Leave it like that. That's perfectly fine. Okay? All right. So moving on. Let's see what else we need to cover today. We have one more practice problem for this, and then we're going to talk about something else. Well, it's the same thing. It's just a different type of conversion. So let's do 33.3. And we are going to convert 24 miles into inches. So what do we need to know? That's the question you need to ask yourself. Well, first of all, if I'm going to go to inches, I know that from between miles and inches, there's feet. So I need to go from miles to feet to inches. So from miles to feet, I need that one. So I'm going to look that up. And you can even, ask Siri on your phone or Google it, and it'll tell you that, or look at your reference page that's in your materials, that 1 mile is the same as 5,280 feet. And we already know inches to feet. 1 foot is 12 inches. So we're going from miles to feet, from feet to inches. So now we know our pathway. We know the journey we have to take. So we're going to turn 24 miles into a fraction by putting it over 1. And then we're going to convert miles into feet first. So we put 5,280 feet on top and 1 mile on the bottom. That allows us to cancel out miles. Now we're going to convert feet into inches. So we need to put inches on the top and 1 foot on the bottom. That allows us to cancel out feet, and now everything is being multiplied into inches. So the answer you're probably going to type into the system is 24 times 5,280 times 12 inches. This is a big number to calculate, okay? I don't expect you to calculate it. I really don't. I expect you to type it in just like that. Now, because the answer is going to be a whole number, I will have that option in the system. But I don't expect you to calculate. I expect you to leave it just like this, and that will let me see that, yes, you put 24 first, and 5,280 second, and 12 third, and you got the right unit of measure, which was inches, so you know exactly how to do the problem. That is what this tells me. So you don't have to go any further. You can leave it like this, okay? If you have to pull out your calculator in order to solve it, then don't solve it when it comes to unit of conversion problems. Leave it in this format. That is what I was trying to convey previously. So let's look at conversions of unit for area. So we've been doing length. What we just did was a length, right? Because it just has the unit of measure without an exponent. But for area, we know there's that exponent of 2. So that adds a different element when we want to convert area from one unit to another unit. So let's look at how we want to do that. Let's do 33.4. Okay. And we want to convert 4 square feet to square inches. So we do the same thing we've done before, and we look at our units of measure, and we know we're going from feet to inches, so we know this is the unit we need. 1 foot is the same as 12 inches. That's all we need, because we're going from feet to inches. That even though there's an exponent here, we're just going to use the same unit of reference. So let's proceed. We have 4 feet, so we take 4 feet square, right, or 4 squared feet. And we are going to turn it into a fraction like always, but we're going to do it a little differently. We have feet with the exponent of 2, so this tells us how many times we're going to write this unit of measure. Because technically what this is feet times feet, right? Because we have feet going in the height and feet going in the length, so it's feet times feet. So we're going to write feet as we're going to treat it like a variable, and we're going to write it twice. So 4 times feet times feet. That's what we have. And that's what this is too. I'm going to put that over 1. So however many, or whatever the exponent is, that's how many times you write it here. So for area, there's an exponent of 2. So we'd write this unit of measure 2 times. Okay? What that means to us is this. We are going to have to cancel it out twice. So I'm going to put 12 inches over 1 foot. That allows me to just cancel the first one. Now I have to do it again. 12 inches over 1 foot. That allows me to cancel the second one. So look what I have though. Now I have inches 1 time, inches 2 times. Inches 2 times. So that is what allows it to be inches squared when we finish, because we should have inches written twice. And when we multiply 12 inches times 12 inches, we get inches squared. We treat it just like a variable, and we combine the exponent. All right, so this will be 4 times 12 times 12. So 4 times 12 times 12 is going to be inches squared, because this is area. It's the area of something. Now, if you can do this in your head, if you can say 4 times 12 is 48, that's fine. And 48 times 12, if you can do that in your head, that's fine. I don't expect that. The one thing I do expect you to see here is the potential for the exponent. So if you understand exponents, you could see that this is being multiplied 2 times, 12 times 12. You could do that. This is another potential answer. But if you're not fully understanding the exponents, this is what you should write. This will be what's in the system. This will also be in the system. And also, because the answer is a whole number, that whole number will be in the system as well. But I don't expect that. If you just want to do this right here, this is fine. Okay, let's do 33.5. I think that you understand what I'm looking for as far as answers in the system is concerned. So use 2 unit multipliers to convert 4 square meters. And when it says square meters, it means meters square. Okay? Square meters, meter square is the same thing. And we're going to convert those 4 square meters to square centimeters. So, centimeters squared. So all we need is our unit of reference between meters and centimeters. And we know that 1 meter is 100 centimeters. That's the only unit we need. So we're going to rewrite this 4 meters, right? Meters twice, meters once, meters twice, over 1 times. And now we're going to use our unit of reference. We're going to put meters in the bottom because we need to cancel those meters out. And we're going to put centimeters in the top because that's what we want to end up with. We're able to cancel one of the m's out. Now we do it again so we can cancel the other m out. 100 centimeters over 1 meter. We can now cancel that other meter out. And now we have 4 times 100. Oops, there should be an equal sign because we're where we need to be. 4 times 100 times 100, and that's in centimeters, and we have centimeters once, centimeters twice, so that's centimeters twice. Okay? Now again, this answer, I will take it just like that. I will also take it just like that. But because it is 100 times 100, it's just ones and zeros, I will also take it like this. We have 4, and 4 times 1 is 4, and then I have 4 zeros behind that, right? 1, 2, 3, 4. I will also take it like this. And the only reason that I do that now is because it's easy. If it's easy to do in your head, then you can do that answer. If it's something that means you have to whip out a calculator to solve it, I'm not going to put that answer out there, okay? Unless it's a whole number. But I don't want you whipping out your calculator for every little thing. I want you to use your brain and try to solve these mentally as much as possible. I'm not going to penalize you because you can't do that. Instead, this is fine. This is the answer that shows me you know exactly what you're doing. This one shows me that you understand exponents and that you get it and that you're a little bit more along the way. This one tells me you completely understand how to do this in your head, that you're good at that. You don't get any bonus points for it, but it just allows me to give you another possible answer that's acceptable. That's all. Okay? Sorry, no brownie points for doing extra math. Let's do 33.6. It's our last one. Hopefully, by the time we're done with this, you understand exactly what the process is. 33.6 says we're going to convert 400 square inches to square feet. And I wrote that out for you just so you can see the way it's going to ask you. This can easily be rewritten 400 inches square to feet square. Same thing. We need our unit of reference, inches to feet, so 1 foot is 12 inches. Okay? So now we can rewrite this into a fraction. We bring it down and we say 400, and we have inches twice, so inches twice over 1. Now we're going to convert this into feet. 1 foot over 12 inches. That allows me to cancel the first one. 1 foot over 12 inches. That allows me to cancel the second one. So now we have 400 times 1 times 1. So that's 400 over. And we have 12 times 12 in the bottom, right? And then we have feet once, feet twice. So feet twice. This is an acceptable answer. That's the answer I want. This is an acceptable answer. Okay? And if you know your multiplication tables and you put 400 over 144, that's an acceptable answer too, but I might not have it in the system. So if you do this and it doesn't take it, just go back to the original. Just type it in like that or type it in like that. Okay? The one that I put my box around here, that's the one I prefer. That's the one I'm going to look for. This one may be in there as an alternative. And I might put this one in there, but chances are it's probably not in there. Because what I have to do is I have to think of all the possible scenarios and all the possible ways that someone might enter the answer, and I have to type it in. So you know for sure, however it ends up is going to be there. Easy mental math is going to be there, right? This is easy mental math because you just put the exponent on the 12. This is fairly easy too, but it's just a process of me having to remember to do it. And if I forget to do this, you can always go back to the beginning and just do that. Put that in, and it'll get marked right. All right, and that is the last practice problem that we have for lesson 33. So I will see you in lesson 34. If you have any questions about converting area, because this is what we're doing, please reach out and ask me for help, and I will be here for you. And that's all I have.